Welcome to Study Loop.
So in this question, we have a claim, and the claim is that a treated mouse beats a non-treated mouse 70% of the time. And we test the claim. We divide a group of 20 mice randomly into 10 pairs. So we have 10 experiments. So we have n equals 10. And we find that 7 out of 10 of the mice treated with the vitamin supplement beat the untreated mice. So fine. So if we say that n is the number of times treated wins, we find n equals 7. So what's the probability of obtaining this result if the claim is true? So the probability that n equals 7 given the claim is the probability that n equals 7 given that n is binomially distributed with 10 trials and a 7/10 chance of success. So we know that from the binomial distribution, this is just 10 choose 7, 0.7 to the 7, 0.3 to the 3. So let's see what that is. 10 choose 7 times 0.7 to the 7 times 0.3 to the power of 3 gives us 0.2668. So part 2, what's the probability of obtaining the result if the claim is false? So what's the probability that n equals 7 given that the claim is false? Well, that's the probability that n equals 7 given that n is binomial with 10 experiments and a 0.5 chance of success on each experiment. Well, that's going to be 10 choose 7 and then 0.5 to the power of 10. So 10 choose 7 times 0.5 to the power of 10 gives us 0.1172. Okay, so let's say that our prior is that the probability that the claim is true is a half. So now what do we think? So we need to update our probability. So what's the probability of the claim given that n equals 7? Well, that's going to be the probability that n equals 7 given the claim times the probability that the claim is true divided by the probability that n equals 7 given that the claim is false times the probability that the claim is false plus the probability that n equals 7 given that the claim is true times the probability that the claim is indeed true. So this is just our standard Bayes theorem. But because the probability of the claim is a half, we can divide these out. So the probability of the claim is true given that n equals 7 is just the probability n equals 7 given our claim divided by the probability n equals 7 given our claim plus the probability n equals 7 given that the claim is false. And we have all of these probabilities. So this is 0.2668 divided by 0.2668 plus 0.1172. And that gives us 0.6948 as our posterior probability that the claim is indeed true from Bayes' theorem. So in order to answer what's the question about our belief, we should favor the possibility that the claim is true. However, However, the power of this test is not particularly high. There's still a large chance that the claim is false. So, however, this does not provide overwhelming statistical evidence.